they tell us. We just know that when you differentiate this, we actually can prove it. But in Fourier series, we do the sign expansion of periodic waves that comes to you. So what does Fourier series say in practice? Fourier series in practice is only telling you that this is a way to get signals in the smallest minute disintegration. So number 2 says that it must be single valued and continuous. When they mean single value, look at the wave. It keeps going so that it can either be a sine wave or a cosine wave. But what do they mean by continuous? Continuous simply means it doesn't damp. If you have a wave that damps, an equation that damps is like this. It's damping until it dies. This process is called damping. So what do they mean by damping? Damping means when something starts from a very high frequency, this is the maximum point, then this is the minimum point. It starts from a height, the vibration starts, the wave starts, and gets to a point where the wave begins to reduce until it dies away and hits this 0 point, and dies away completely. Let me give you an example. Even in practice, even relationship damp, the energy, the enthusiasm you use in starting a relationship, at the end of the day, it damps. That means the relationship breaks up, or either it gets to a point where there's no more vibes, and that's the point where C finish, they enter. Number 3, it must have a finite maximum or minimum number within a period. Let me show you what it is. This is the equation. Let's just say this is a sinusoidal graph. Let's just say this is a sine graph. Note, these all things are vibrations of waves. These are wave displacements. So this point is what? The maximum. This point is what? The minimum. So they are telling you for Fourier series to be applied, it must have a finite maximum or minimum number within a period. From this place to this whole place, the whole of this place to this place is a period covered. That's why they say rainy season period, dry season period. All these things are all periods to cover. Now, the last but not the least is in functions using Fourier series. The integral over a period of time must converge. The integral of the function. Let's just say this is the function f of x. For something to convert, that means in mathematics, we put it like this. You are looking for the absolute value of that function, f of x. When you look for the absolute value of a function, it means that you have normalized either the negative or the positive part of that function. You don't even care. Like in the signal now, you don't even care if this, of course we know that anything that goes down here is negative, anything that goes up here. But now we are considering this whole thing and putting an absolute value of this function so that it will converge. So when it converges, something happens. In power series, let me show you what happens. Sigma to infinity, n is equal to 0. You can see x raised to power n, that's the number of times over n factorial. It moves. You can see this is in terms of what? Power series, f of x. Okay, now let's use the summation aspect of it. So let's do the normal series expansion. Let me show you. You have f of x equal to, sigma means the summation, infinity, n equals 0. Then once we be starting from the k is representing the number as they increase or decrease. So you have k naught, which is the first one, plus you have k1 bracket x plus a. This, we are now seeing the maximum and the minimum limit where it's supposed to be continuous or discontinuous, plus k2 bracket x plus a raised to power 2. You see that it's increasing, plus k3 bracket x plus a raised to power 3 dot. You see that it's increasing. Let me clean to show you. Then we now have we have kn, which is the number on k infinity bracket x plus a bracket infinity. That's where it's stopping. So we assume that we are stopping it. So what are we saying? For a function to actually be continuous, the function will either be increasing or decreasing in power. When it gets to the series, it cannot be discontinuous. If it's discontinuous, that means you can't have like a series. You have 1, 2, 3, 4. This is an increasing series. It's increasing with a pattern, and this process is called the Dirichlet conditions. Thank you. See you in the next class.